Hello everyone, myself Anil BV, second year student from Sri Venkateshwara College of Engineering. Today I am going to talk about Markov chain, which is one of the important topic in third semester mathematics for CSE stream. Markov chain. Let us see the introduction first. Markov chain is a mathematical concept used to model random process or a system. It is named after the Russian mathematician Andrei Markov. Markov chain is a sequential of random variable where the probability of each variable is depends only on the previous state. What are the elements of Markov chain? Markov chain consists of a set of states and a set of transition probabilities. The states represent the possible condition or state of the system. The transition probability defines the likelihood of moving from one state to another state. Transition matrix. A transition matrix is a square matrix that represents the transition probabilities between the states. Each element of the matrix represents the probability of transitioning from one state to another state. The sum of each row in the transition matrix must be equal to the 1. Markov properties. Let's see what are the properties of the Markov chain. The Markov property states that the future states of the system depends only on the current state and not on the past states. This property makes Markov chain memoryless and simplifies their analysis. The Markov property is a key assumption in the Markov chain modeling. As you can see in the picture, Markov property. Absorbing state. An absorbing state in the Markov chain is a state from which it is impossible to transition to any other state. Once the system reaches an absorbing state, it stays in that state indefinitely. Absorbing state have the transition probabilities of 1 from the state itself and 0 for all the other states, as you see in the picture. Next topic. An ergodic Markov chain is where it is possible to reach any state from any other state. In an ergodic Markov chain, all states are interconnected and have positive probabilities of transitioning between each other. Ergodic Markov chain have steady state probabilities and converge to stationary distribution. Steady state distribution. The steady state distribution of Markov chain represent the long-term probabilities of being in each state. It is a probability vector that remains unchanged over time. As you see the example of the Markov chain, the steady state distribution are often used to analyze the behavior of the Markov chain. Next concept, the Chapman-Kolmogorov equation describes the probability of transitioning between the states in a Markov chain. You can note down the example for your reference. These equations are useful for calculating the probability of reaching a particular state after a certain number of steps. These equations can be used to study the behavior of complex Markov chains. Next concept is applications of Markov chain. Let us see the application. What are all the applications are there in the Markov chain? Markov chains have a wide range of application in various fields, including the finance, biology, physics, and computer science. Currently, we are also using it in the mathematics also. They are used to model stock prices, population dynamics, particle interaction, and network protocols, among others. Markov chain provides the valuable insights to the behavior and evolution of the complexes. As you can see in the picture, this is an example of Markov chain for finite and discrete Markov chain. Page rank algorithm. The page rank algorithm developed by Google is based on Markov chain. It determines the importance of web pages by analyzing the link structure of the World Wide Web. PageRank uses a Markov chain model to rank web pages based on their likelihood of being visited. Next, see what are the limitations of the Markov chain. Markov chain assumes that the future state depends only on the current state, which may not always be true in a real world scenario. They require the system to have a finite number of states, which may not be suitable for continuous systems. Markov chain can be conventionally expensive to analyze for large state spaces. Let's see what are the higher order Markov chain. Higher order Markov chain consider the dependency of previous n state instead of just immediate previous state. These allow for modeling system with more complex dependencies and capturing longer term behavior. Higher order Markov chain requires more computational resources and larger data sets for this analysis. Hidden Markov models. Let us see what are the hidden Markov models. Hidden Markov models are the type of Markov chains where the state are directly observable. HMMs, which are also known as the hidden Markov models, used in speech recognition natural language processing. They involve estimating the probability of hidden states and based on observable outputs. As you can see in the picture, this picture will give the output. Let us see what are all the applications in natural language processing. Markov chain are used in natural language processing for the tasks such as text generation, language modeling, and part of speech tagging. By modeling the transition probabilities between the words or states, Markov chains can generate the coherent and realistic sentences. They can also be used to predict the next word in a sentence or assign the part of speech tags to words. Markov chains to Monte Carlo. Markov chain Monte Carlo methods are used for sampling from complex probability distribution. These algorithms generate a Markov chain that explores the probability distribution and converges to the desired distribution. This has application of inference and machine learning and statistical physics. What are the limitations of Markov chain in Monte Carlo? These methods can be computationally intensive and requires a large number of iterations to converge. The convergence rate of these limitation Markov chain Monte Carlo algorithms can be slow, especially for high dimensional distribution. Choosing the appropriate proportion of distributions and turning the parameters algorithms can be challenging. Let us see the conclusion of the Markov chain. Markov chain are powerful mathematical tool for modeling random process and systems. They have the applications in various fields and provide the insight into complex behavior. Understanding the Markov chain and their properties. If you have any queries, comment below. Thank you for watching my video. Thank you.